Now, for today, we're going to move in still the segments. This is actually going to meet either inside of the circle, outside of the circle, but now I'm not looking at the angles. I'm looking at the length of the sides. This is going to be a little bit easier. Now here it says solve for x. Assume the lines which appear tangent are actually tangent. That comes when my measurements are outside of the circle. Now here, number 17, what I'm going to do, I see there's two segments, right? This is one of my segments. It's made by the measurement x and 21. What I'm going to do first, let me multiply those two measurements. X times 21. So let me just write 21 times x is going to be equal to, I see another segment here. It's made by the measurements 15 and 14. So I'm just going to go 15 times 14. So 21 times x, I know that's 21x. 15 times 14, that's 210. Now let me divide both sides by 21. So x, in this case, happens to be 10. So pretty nice, right? Look at the two measurements that make a side or a segment and multiply them together. Look at the measurements that make the other segment and multiply them together as well. Now looking at number 18. One of my measurements is made by the sides x and 10. So let me multiply that. 10 times x. This is equal to, my other segments is made by the measurements 8 and 15. So I'm going to go 8 times 15. So then I get 10x is equal to 120. Divide both sides by 10. X is equal to 12. Okay, so these were pretty cool. Now the question is, what happens when my segment is outside? Okay, now this is going to be a little bit more work, okay? Let me take a look at this segment. And the first thing that I see is how much of the segment is outside of the circle. So 10. And I'm gonna multiply this, right? My parentheses here almost look like a circle. So notice 10 is outside of my parentheses. 10 is outside of the circle. Now inside my parentheses, I'm gonna write down how big is the entire segment, the whole thing combined. It is x plus 10, right? Because part of it is x, part of it is 10. So combined, the whole thing is x plus 10 equals. Now let me take a look at my other segment. First thing I ask myself is how much is outside of the circle? 9. Now the whole segment, I can call it, for right now, I can call it 9 plus 21. Because remember, I have to combine this, 9 plus 21. I could call it 9 plus 21, or I can just say, you know what? 9 plus 21 seems too lengthy. I'm just going to call this 30. Right? I can combine it. My first parentheses, I couldn't combine. X plus 10, I have no idea what x is. But 9 plus 21, yeah, I can combine that, right? I'm just going to write 30. I remembered distributive property. Remember, distributive property, multiply the number on the outside to the numbers on the inside. So on the left side, let me multiply the 10. So that gives me 10x plus 100. Now here, 9 times 30 is 270. To get the 10x by itself, the plus 100, let me move it over as a minus 100. So I get that 10x is equal to 170. Divide both sides by 10. So x equals 17. Good. Let's take a look at number 20. We focus on this segment first. It doesn't matter which one you look at first. Outside of the circle is 9. And I'm going to multiply this by the whole segment. x plus 9. Now let me take a look at the other segment. It's this one right here. Outside of the circle is 15. I'm going to multiply this by the whole segment, but the whole segment is outside, so 15 as well. It is okay to have the same number twice, because first is how much is outside of the circle, and then how much is the whole thing. The whole thing is outside, so it is okay to be the same number. All right, so let me do distributive property. Let me distribute the 9. So that gives you the 9x plus 81 equals, now on the other side, 15 times 15 is 225. Okay, I want the 9x by itself, so this plus 81, let me move it over as a minus 81. So I get the 9x is equal to 144, right? 225 minus 81. Now let me divide both sides by 9. So x equals 144 divided by 9 is 16. Pretty cool. Now, gonna get a little more challenging. Let's take a look at number 21. Okay, now this is a little more challenging. Now here, I'm not asking to solve for x. I'm asking to find UW. Find the measurement UW, the segment UW. So the distance between U and W. But I see an x in there. So let me solve for x, and then I'll come back to this question here. Okay, so first I see one segment. Remember when the segments were inside, I just multiply the two parts. We did that for example 17 and 18. So I'm just gonna go 2x plus 2 times 12 equals, my other segment is made by the measurements 9 and 8. So I'm gonna go 9 times 8. I know that the distributive property says the number outside of the circle, outside of the parentheses multiplied to the terms on the inside. It never said I have to go from left to right. I can go from right to left. So I'm gonna multiply 12 times 2x, and then 12 times 2 equals 72, right? 9 times 8. My plus 24, let me move it over as a minus 24. Now 72 minus 24 is equal to 48. So I have 24x equals 48. Let me divide by 24. X is equal to 2. I read the instructions, find UW, not X. So if this was a homework, I type in 2, boom, this is wrong. Now UW, if you notice, is this whole segment. 2x plus 2 plus 12. I know X equals 2, so this whole segment really is 2x plus 2 plus 12. That's the whole segment, right? From U to W. But I know x equals 2, so let me rewrite this. Instead of x, let me put a 2. So 2 times 2 plus 2 plus 12. I'm using parentheses because if I don't, 2x looks like 22, and it is not. I know I have to multiply first, right? So 4 plus 2 plus 12. Add all this, and this is 18. Nice. So solve for x and then use it. Find UW, find the value of x and then use it. Now here, I'm asking for the measurement SG. I see an x. Again, let me solve for x and then I'll come back to the question. I'm looking at this segment right here. It's made by the measurements x plus 3 and 14. This other segment is made by the measurements 7 and 16. distribute. So on the left side, I have 14x plus 42. On the right side, 7 times 16 is 112. So this plus 42, let me move it over as a minus 42. So that's going to give me that 14x is equal to 70. Divide by 14, so I get that x is equal to 5. I type this in, 5, it's wrong. I'm asking, in this case, for the measurement SG. SG is only this measurement, from S to G, which is x plus 3. But I know x equals 5. So I'm really looking at 5 plus 3, better known as 8. Okay, so this got a little challenging. Even more challenging, let's take a look at number 23. There's a bunch of x's in there. And I'm going to ask you to solve for ln. So ln is this whole thing. If you notice, I have to do 2x plus 8 plus x plus 7. I have to add everything. So it would be nice if I knew what x is. Okay. So I guess I had to figure out. I just wrote this, so I know what to come back to, okay? Now, let me solve for x. I'm going to be looking at this segment. It's made by the measurements 2x plus 8 times x plus 7. And this other measurement is made by the numbers, by the measurements 20 times 27. Good thing we learned how to factor it in algebra 1. That's going to come very, very handy right now. So let me distribute 2x times x is 2x squared. 2x times 7, 14x. Then 8 plus x, 8 times x is 8x. And 8 times 7 is 56. And this is all equal to 540. When I combine my like terms on the left, I get 2x squared plus 22x plus 56 is equal to 540. Okay, so now I remember when we factored in algebra 1. So last year, in algebra 1, I remembered factoring. When I was going to solve by factoring, one of my sides had to equal to 0. So this plus 540, let me move this as a minus 540 because I want the right side equal to 0. So I have 2x squared plus 22x. Now 56 minus 540 is negative 484. I remembered it was easy to factor when my first number was a 1. I remember my algebra 1 teacher called it the leading coefficient, the first number. I see they're all even numbers, so why not divide everything by 2? Each of my numbers, I'm going to cut it in half, right? I'm going to divide it by 2. So it's going to be 1x squared plus 11x minus 242. It's equal to 0. 0 divided by 2 is still 0. So now I'm looking for, I remember my teacher used to do this thing called diamond, and I'm looking for two numbers that multiplied equals negative 242, but when I add them is equal to positive 11. Because multiplied equals negative, I know my signs are different. Now think of the factors of 242. Intentionally, for this example, I picked a hard number. Your homework will be a little bit easier. Remember how to do the factors. This is a refresher from Algebra 1. my factors. The factors are basically what multiplied by equals 242. And I'm gonna go 1 times 242. I know when the signs are different, I have to subtract this. And I ask myself, when I subtract this number, is it equal to 11? No. Okay. How about 2 times 121? Right, that is 242. When I subtract this, no, not equal to 11. How about 3? And then you're like, huh, 3 times what? Want to help you guys out how to figure it out. The way I came out with this product, I used division. 242 divided by 1 gave me that. 242 divided by 2 gave me that. Now 242 divided by 3, it gives me a decimal. So 3 is not a factor. Notice how on the left side, I'm increasing my numbers. 1, 2, 3. So I'm gonna go 4. Now for me to find out the factor of the other one, I'm gonna use division. 242 divided by 4, it gives me a decimal. So guess what? It doesn't work. 5 is not gonna work either. 242 divided by 6 gives me a decimal. So guess what? 6 is not gonna work either. Now 242 divided by 7, it gives me a decimal. So 7 doesn't work either. 242 divided by 8 gives me a decimal. So what I'm trying to prove here is that some cases are not going to work, but keep trying. Keep trying. Eventually, something has to work. Divided by 9 doesn't work. 242 divided by 10 doesn't work. By 11, so I said 9 didn't work, 10 didn't work. By 11, I get 11 times 22. Okay. If I subtract those, that equal to 11? Yes. So my answers are going to be positive 22, negative 11. Intentionally, like I said, I chose a big number. But notice I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and boom, eventually at 11 it worked. That was refresher from Algebra 1. But I remember what we used to do here, we will split this as x plus 22 times x minus 11 is equal to 0. You can see where I got the plus 22 and the minus 11. But then the way we solved this was let each of my parentheses equal to 0. My Algebra 1 teacher said the zero product property. When I'm multiplying two things and my result is equal to 0, one or the other or both of my factors are equal to 0. So then I look at my first parentheses. What value of x will make x plus 22 equal to 0? And then I will say if x equals negative 22, right? Negative 22 plus 22 is 0. Then I look at my second parentheses. What value of x will make x minus 11 equal to 0? Then I will say the x equals 11. Your Algebra 1 teacher might have said, look at the opposite number. Notice how my digits are the same, just my signs are different. So x is either negative 22 or x equals positive 11. However, x cannot be negative, right? The measurement of a segment cannot be negative. So negative 22 will not make sense. So I'm going to say x equals 11. The hard work was really solving for x. Now, I remember I said I was going to come back to this. I'm trying to solve 2 times x plus 8 plus x plus 7. I know x equals 11. I couldn't use the negative number because it's going to give me a negative length. So x equals 11, just use it now. So I'm going to say, let's see, 2 times 11 plus 8 plus 11 plus 7. I have to do multiplication first, right? So 22 plus 8 plus 11 plus 7. Add all that. 22 plus 8 plus 11 plus 7 happens to be 48. Pretty cool. Okay, let's take a look at number 24. Find the measurement DF. So from D all the way to F. Just for me to know what I'm coming to, what do I have to come back to? This is x plus 1 plus x minus 4. So as long as I know what x is, easy. Okay. What I'm going to do is solve for x first. The segment, the big segment that I gave you here, it is made by the measurements x plus 1 times x minus 4. The other segment is made by the measurements 6 and 6, so 6 times 6. So distribute first. That's going to give me x squared minus 4x. Distribute the 1. It's going to give me plus x minus 4. And then here, 6 times 6 is 36. When I combine my like terms on the left, I get x squared minus 3x minus 4. It's equal to 36. I want the right side equal to 0, so this positive 36, let me move it over as a minus 36. So I have x squared minus 3x minus 40 is equal to 0. Okay, so now let's see. I'm looking for two numbers that multiply equals negative 40. When I add them, is equal to negative 3. Because multiplication is negative, signs are different, and I'm hoping you guys will say 5 and 8. Right, the way I find out is 1 times 40, and then 2 times 20. 3 doesn't work. 4 times 10, and then 5 times 8. So it's going to be, the big number should be negative, because when I combine it, it's negative 3. So positive 5, negative 8. So this breaks down to x plus 5, x minus 8 is equal to 0. So the values of x that will make that equal to 0, I'm going to say x is equal to negative 5 or x is equal to positive 8. Remember using opposite signs. X cannot be negative 5 because I'm going to get a negative result. So I'm going to say x equals 8 then. So when I come back to what I needed to do, I'm just going to go 8 plus 1 minus 4. And then oh no, here this is supposed to be an 8. Okay, so x plus 1 plus 8 minus 4. I forgot, sorry. So it's c8 plus 1 plus 8 minus 4. That happens to be 13, right? So my whole measurement is 13. Let's finish this thing up. Let's take a look at number 25. Last stretch. We're going to be looking at circles. One cool thing about circles that it says, if I have x minus h squared plus y minus k squared, it's equal to r squared. My centered is going to be the values h and k. Okay, one thing I want to emphasize here. It's going to be what I'm going to have inside my parentheses. Just change the sign. So my parentheses had a minus, I change it to positive. If I had it as a positive, I'm going to change it to negative. And another thing I'm going to emphasize too is this thing right here is radius squared. Now, we learned back in Algebra 1 that the squared, because look, I have something squared plus something squared. You learn your parabolas. Remember in algebra 1, you learned that y is equal to x squared. It gave you a U-looking shape. So each of those are parabolas, and I want them to connect. So on inside my parentheses, I'm always going to have a plus, because I'm going to have a parabola going like this, another parabola going like this. So I combine them with a plus sign. If I was to use a minus sign, the sign in between my parentheses is very important. If I was to use a minus sign, my parabolas will be not connecting. And that's what we're going to call hyperbola. But we're not going to see that this year. So I want my parentheses to, my parabolas to combine. So I'm going to use a plus in between my parentheses. And then last thing, I want to emphasize here at the end, I have radius squared. Okay. So here, let's take a look at number 25. Identify the center and the radius of each. I'm looking at my numbers inside the parentheses. My centered of this circle is going to be 4, 10. Notice I switch them. Again, if they were negative to begin with, change it to positive. If they were positive to begin with, change it to negative. So my centered is easy to see. Now for the radius, I know radius squared equals 36. I want to know what's the radius. Okay, we talked before. The way I'm going to undo a square is by doing the square root. So r is equal to 6. The square root of 36 is equal to 6. Now it is nice when I get the square root of a perfect square. Now sometimes I might not. I might get that r squared is equal to 18. So r is the square root of 18. But remember, we learned how to simplify that out. It's 9 times 2, so 3 radical 2. Some of your radius are not going to be a whole number. It's going to be a radical, right? We talked about that before. Now, I don't want to worry about how to type this. Like, do I put a space after the comma? Do I not put a space after the comma? How am I going to type this? What I'm going to give you, when I ask you for the centered, I'm going to give you the parentheses, and I'm going to give you the comma already. I just want you to type in, there's going to be 2 spaces. I want you to type in your values. If it's negative, do put in a negative though. Okay, so looking at number 26. The center is going to be 6, negative 5. Notice my values, I switched the signs on both, right? If it was negative, I wrote it as positive. If it was positive, I wrote it as a negative. My radius, I know 64 is r squared. So my radius is going to be the square root of 64. And write it in simplified radical form. In this case, happens to be a whole number. 64 is a perfect square. But then I'm going to ask you guys to graph this. Okay. Reading the equation, I can identify parts, right? My centered of this circle is the -3, -2. Right, I got the values from there, gotta switch the signs. So I know my center is -3, -2. My radius is the square root of 16. Because remember, 16 is r squared. So r is the square root of that. The cool thing is that this is a perfect number. This is a perfect square, so my radius is 4. So how am I going to graph this? My center is the point -3, -2. That's not that bad. My center can be graphed easily. It's right there. Now my radius is 4. So what I'm going to do from my center, I'm going to go 4 up. I can count my squares. I'm going to go 4 to the right, 4 down, and 4 to the left. In your homework, I'm going to give this to you as a multiple choice. Notice how each of my squares I'm counting by 1. Here, in your choices on your homework, each of the squares you're counting by 2. So be careful on that, okay? So I counted 4 spaces. Remember, I was counting by 1. In your choices, you will be counting by 2. So do not count 4 squares. Be careful in the counting. Now, this point that I drew was for me to know exactly where my circle is going to go through. And I have a very good idea where this goes through. It's right there. Now let's assume that's a circle. That's the best I can do freestyle. Your case is going to be multiple choice. Don't want you to worry about the drawing. I want you to understand more than anything. Now for number 28, I'm going to find the center. My X value is easy, but my Y value it has nothing. So it doesn't have parentheses. So my Y value is going to be 0. There's no such thing as a negative 0. So my center is going to be 2, 0. That's easy to graph, right? That goes right there. That's my center. As a matter of fact, let me do it in black again. It's easy to graph my center. Now my radius is the square root of 19. Now this is not a perfect square. Now this one, I'm going to round it to the, I'm going to use my decimal number. I'm going to use my calculator to simplify this, to give me a decimal. Since I'm graphing, I'm going to use a decimal number. I type the square root of 19 and it tells me is 4 point something. In this case, 4.36, right? 4 point something. So what am I going to do with this? So my radius is 4 point something. So from the center, had to go 4 point something up. So I'm going to go 4 spaces and a little bit more. Now, if I ask you to graph this on paper, believe me, I'm not going to grab a ruler and I'm not going to be like, hey, I said 0.36, not 0.47, right? I'm not going to measure. All I expect for you to do is 4 point something. So a little bit more than 4. So from the center, let me go 1, 2, 3, 4, and a little bit more to the right. From the center going down, let me go 1, 2, 3, 4, and a little bit more. From the center, let me go 4 and a little bit more. Right, 4 point something, 4.36. It's just 4 point something. So when it's not a perfect square, I'm not gonna be perfectly. I'm gonna be a little bit off. Let me draw my circle. And there. And lastly, I'm gonna ask you guys to graph this. I mean to type in the equation of this. Use the information provided to write the equation of each circle. The constant distance from each point to the center is called radius. So here I have the radius is 8. Your homework, I might say, the constant distance from each point to the center is 8. So I might use the word radius, or I might use the phrase, the constant distance from each point to the center, right, instead of the word radius. So, okay, the first part is pretty simple. I see my X, my Y value. I'm gonna switch them. I'm gonna switch the symbols. My first parentheses, I'm gonna have X plus 2. And all this is square. My X will be lowercase x. Do not capitalize the X. For the homework, I'm gonna give you the parentheses all squared. So you just have to type in the X plus 2 in between. For my second parentheses, I'll give you the parentheses all squared. You just have to type in what's inside the parentheses, and I'm gonna go y minus 4. Couple things. Notice on my values, I switched the signs. So from a minus 2, I wrote plus 2. From a positive 4, I wrote minus 4. Another thing too, my letters. This one's an X, this one's a Y. So be careful on that. You have to type in X plus 2 and then Y minus 4. And then in between, I said I don't want to deal with hyperbolas. I don't want my parabolas to to be opposite sides. I want them to combine. So in between, I must have a plus sign. And then equals radius squared. I know my radius is 8, so radius squared is 64. So here, right, 8 times 8. That's it. That's the equation of my circle. Now looking at question number 30, to finish this, my first parenthesis is going to be x minus 3 all squared. Don't forget to switch the sign. My second parenthesis is going to be y plus 3 all squared. Again, don't forget to switch the sign. Don't forget the first one has an x, the other one has a y. Don't forget the letters. There must be a plus in between. Equals. Okay, now this one, 4 radical 10 all squared. It would be nice if I just have the 4, right? I remember we saw this when we saw Pythagorean theorem. I will ask you, when there's a whole number, it's easy. When it's a radical only, it's easy. When it's both, do individuals. So 4 squared is 16. If it was just the radical with the square undo each other, so it's just 10. Now multiply these two, so 160. I'm gonna write 160.